Subtopic 8.3 Thermodynamics. Now let us focus on these two learning outcomes. C. Define the thermodynamics processes: isothermal, isochoric, isobaric, and adiabatic. Last one is to interpret pressure and volume graph for all these four thermodynamics processes. Next, let us define these four processes. First one is isothermal. Isothermal is the process that occurs at constant temperature. So along this process, the temperature of the system or the temperature of the gas is always constant. Next, isobaric. It is a process that occurs at constant pressure. That means the pressure of the gas along this process is constant. Next, isochoric. And it has another name, which is isovolumetric. It is a process that occurs at constant volume. That means the volume of the gas is constant along the process. The last process is adiabatic. It is a process that has no heat flow in or out of the system. That means for this process, the amount of Q is 0. Right. Now, let us have a look in detail on the first process, which is isothermal process. You know what? This process obeys Boyle's law. Boyle's law says the multiplication of pressure and volume is always constant along the process. Now let's have a look on the graph. I choose this point. Okay, let us choose this point. Pressure 1 multiplied with volume 1 is equals to the value of pressure 2 multiplied with volume 2. And if we choose any point along this curve, okay, let's say I choose this point, the pressure times volume is equal to the pressure times volume on any point on this curve. And you know what? This curve represents a isothermal process, and it has a value of temperature. Now let us relate this process with the first law of thermodynamic process equation. So this is the equation. You know what? Because of this process is happen at constant temperature, so the internal energy of the gas is also constant. Therefore, the change of internal energy becomes 0. Thus, the first law of thermodynamics becomes Q equals to W. The next process is isobaric. Okay, remember this process occurs at constant pressure. So as we can see on the graph here, the amount of pressure is constant. Meanwhile, another value which are volume and temperature is changing. So this process obeys Charles' law, where Charles' law says the volume 1 over T1 is equals to volume 2 over T2. So on the graph, the volume 1, which is on this point, over T1, which is this curve, equals to V2 over T2. These two red curve is actually the isothermal process. And please take note, T2 has a higher temperature than T1. Alright, as the gas heated, the gas then expand. and its temperature increases. Therefore, this graph goes to the higher temperature. To relate this process, this isobaric process, with the first law of thermodynamic, so the expression is stay the same. Q equals to delta U plus W. The example for this process is a boiling water. The next process is isochoric, and it has another name, which is isovolumetric. Alright, still remember, this is a process that occurs at constant volume, so the volume is stay the same. Since then, no work done because the volume is stay the same. And this process obeys Gay-Lussac's law, which is pressure 1 over temperature 1 equals to pressure 2 over temperature 2. As we can see on the graph here, pressure 1 over temperature 1 equals to pressure 2 over temperature 2. And any ratio of pressure and temperature along this line or graph is constant. Alright, now in terms of first law of thermodynamic, this is the expression. The work done becomes 0 because the volume is constant. Therefore, Q is equal to delta U. And delta U is actually U2 or U final minus U1 or U initial. The next process is adiabatic process. It defined as a process that occurs without heat transfer into or out of the system. It telling us that the amount of Q is 0. Alright, let's have a look on this graph, PV diagram. This is the example of adiabatic expansion from P1 decreasing to P2. At the same time, the temperature of the gas is decreasing from T2 to T1 as the gas expands. Now let us relate this with the first law of thermodynamics. In this expression, we have to substitute Q0. So the expression becomes work equals to negative change in internal energy. That means the internal energy is decreasing. Alright. This expression telling us that as the gas expands or as the work done by the gas use its own internal energy to do work. That is why here we get a negative change in internal energy. Now let us proceed with example 2. So from this example, we have to sketch PV graph for all the thermodynamic processes. And we have to sketch them on the same axis. To sketch this, first step is to have the axis. Okay, and we have pressure and we have volume or x-axis. Now let us start with the first process, isothermal. Okay, here we sketch two curves. So we have two isothermal processes. This is the expansion for isothermal. You can choose either to sketch expansion process or compression process. Next, let's have a look on isovolumetric at constant value. At constant volume, this is a decreasing in pressure and at the same time decreasing in temperature. Next, isobaric, constant pressure. Constant pressure, we choose the expansion isobaric process. Next, the last one is the expansion adiabatic process. So the expansion process causes the temperature of the gas decreasing from this temperature to this temperature. Actually, there is another alternative answer for this example. Okay, we can also have this answer. Like here we have expansion thermodynamic and then decreasing in pressure for isovolumetric and compression isobaric and then compression adiabatic. Next example, example 6. 8.5 moles of an ideal monatomic gas compressed adiabatically. 8,300 joule of work is done on the gas during the process. The temperature of the gas increases from 350 Kelvin to 800 Kelvin. Alright, the first question is, what is the change in internal energy of the gas during this compression? Alright, we apply the first law of thermodynamic and we have delta U equals to negative W. And we know that the work is work done. Therefore, we have to have a negative here. And hence, the delta U or change in internal energy is 8,300 joule. Next question, we have to sketch PV graph for this process. Alright, here we have the axis and then we have these isothermal processes with two different temperature, 350 K and 800 K, and this is the compression. Why the compression? Because the temperature is increasing. Level P and V. Okay, that's all.